Okay, this is Tuesday and Wednesday's block lesson that like 94% of you missed because you were singing songs with the guitar guy, which is awesome. We're starting chapter 8, which is exponential and logarithmic functions. Chapter 8 is my favorite chapter, easily. In fact, the day you missed today was my second favorite day of the year, and my favorite day of the year is next block day. Exponential functions are extremely practical and useful and important, and they appear all over the place in the real world. And I love it. An exponential function is whenever your variable is a power. So y equals 2 to the x, y equals 6 to the x. Anything where the variable is the power is an exponential function. These are not polynomials. Okay, we've spent a lot of time learning about polynomials and all the rules about them and linear and quadratic and cubic, but these are not polynomials. You know y equals 2x, that's linear. You know y equals x squared, that's quadratic. But y equals 2 to the x is exponential. A lot of people say something has exponential growth, but really it has quadratic growth. I'll try to make that clear as we move on. Y equals 2 to the x is the parent function. It's the basic, plain, simple one, and we're going to graph it. I'm actually going to do this over on the computer, so you can follow my mouse as I do it from here, and I'll talk a little quieter now. We're going to graph from -3 to 3. And of course you can follow along at home or just watch as I go. And I'm going to plot the points over here as we go. I'll start with 0. I'm plugging this 0 in for this x up here. So I'm doing 2 to the 0, and 2 to the 0 is 1. Anything to the 0 power is 1 except for 0, which is kind of another issue. 2 to the first power is 2. 2 to the second power is 4, and 2 to the third power is 8. And suddenly we've got kind of a curve here that looks sort of like a quadratic curve, but it's not. Let's go to the other side. 2 to the -1, I'm plugging -1 in for x. 2 to the -1 is a half, because the negative power flips the fraction over. 2 to the -1 is a half. 2 to the -2 is a quarter, and 2 to the -3 is an eighth. I'll write that one out. 2 to the -3 is really 1 over 2 to the third, which would be 1 over 8, which is 0.125. You can see that this graph has this curve that, if you look at it going to the left, is getting closer and closer and closer to the x-axis, but it will never actually touch it. If I graph the whole function the way that it's written over here, the curve gets closer and closer to the x-axis without ever touching it. If I think about doing something like, let's say, 2 to the -100, well, that's really 1 over 2 to the 100. Sorry, not 200, 2 to the 100. And that's a very, very, very large number on the bottom, but it makes the whole fraction incredibly small. It's not 0, and it's never negative, but it gets very, very close to 0 without ever touching it. Whenever there's a graph that gets very, very close to a number without touching it, we call it an asymptote. And this graph here has an asymptote at y equals 0. Asymptote is spelled and looks kind of funny. Asymptote, and the asymptote here is the line y equals 0. We can have asymptotes that are anything. They can be vertical or horizontal lines. They can even be diagonal sometimes, although we won't see those. And the graph could be really anywhere, but every exponential function has an asymptote somewhere. That's 2 to the x. Here's 2 to the x graphed again, just copy it over there. Now we're going to do 3 times 2 to the x. So I'm still going to plug in -3, -2, -1, 0, 1, 2, 3. Well, I'll start with 0 again. 2 to the 0 is 1, times 3 is 3. 2 to the first is 2, times 3 is 6. 2 to the second is 4, times 3 is 12. And 2 to the third is 8, times 3 is 24. Now I can't fit 24 on the graph the way that it looks right now. But that's okay. You can see how high it's getting and how much more quickly it's getting high. I go the other direction. 2 to the -1 is a half, times 3 is 3 halves, and 3 halves is 1.5. 2 to the -2 is a quarter. A quarter times 3 is 3/4, and that's 0.75. 2 to the -3rd, now, 2 to the -3rd is an eighth So 3/8 is 0.375. Those points are all there. It still is getting closer and closer to the same line of y equals 0. I'm going to try and clean that up a little bit. I'm not using my pen and it's harder. Yeah. But it's never actually touching that line. It has the same asymptote. What you'll note, though, is that all the y values are just 3 times higher. It goes from 1 to 3, from 1 to 3, 2 to 6, 4 to 12. All the y values got 3 times higher because it was just 2 to the x times 3. Moving on. All the types of equations that we've graphed so far have had some sort of critical point. Absolute value at a v, at a corner of its v. Parabolas had the vertex at their u. Even the square root functions that we did, we had what we called the starting point. It was down there. Exponentials don't really have such a nice critical point. There's things that we can worry about and things to look for, and I call it the 0, 1 point, which isn't like a mathematical thing of any sort. I'm really just talking about this point here, where the base is brought to the 0 power and comes out to 1. 2 to the 0 is 1. Now, there wasn't a 0, 1 point here, and there's not going to be a 0, 1 point much of the time, but that's kind of the idea of the critical point that you're moving around. This graph follows the exact same rules that everything else we've been doing does, with an A, an H, and a K. Y equals K is your asymptote, always. This number B is called your base. If the base is bigger than 1, the graph is going to go up. It has growth. If B is less than 1, the graph has decay, and that's absolute values. So don't worry about positive or negative. B will always be positive right now. The A value does the dilation. It's also called the coefficient of growth or the coefficient of decay. But A, H, and K do the same things they always do. If A is positive, the graph goes up. If A is negative, the graph goes down. If A is larger, the graph increases faster. If A is smaller, the graph increases slower. H moves the graph left and right. K moves the graph up and down. Your book actually has really good examples of this. I'm not super thrilled with your book in general, as you know, but this section it does very well. Okay, let's graph this. Right now, this has an A value of 2, H value of 0, and a K value of -4. You don't always have to plug in these 3 points. We're going to do this for today and for your homework, but eventually you'll find a faster and better way to do this. -3, -2, -1, 0, 1, 2, 3. Well, I'll plug in 0 first. 1/3 to the 0 is 1. 2 times 1 is 2, minus 4. It's -2. Now, in class, I've asked which numbers would be easiest to do next. Most people said 3. They said plug in 3 because they thought 1/3 times 3 is 1. But it's not 1/3 times 3, it's 1/3 to the third. And 1/3 to the third is a 27th. It's 1/3 times a third times a third. Oh, where'd that go? If I keep multiplying these thirds, I'm going to get a 27th. I don't want, and that's okay, I mean it's 1/27th, and I'll calculate that later. But 1/3 to the third isn't a whole number. The easiest one to do is actually going to be -1. 1/3 to the -1 is 3, because the negative power flips the fraction over. It's the reciprocal. So 1/3 to the -1 is 3, times 2 is 6, minus 4 is 2. Let's get this graph. Got these so far. To -2, 1/3 to the -2 is 9, because it's 3 squared, so 9, 18, 14. Do 3. 3 to the third is 27, times 2 is 54, minus 4 is 50. So I have this. My graph's getting very large very quickly, which happens. Other direction, 1/3 times 2 is 2/3, minus 4. Well, at this point, I'm going to do it on my calculator. You don't really need it for this, but you sure can. I'm going to do 2 in parentheses 1 to the 1 divided by 3 to the first minus 4. Negative 3.3. I'll do 2. I can hit second enter and pull up my previous equation and put a 2 here and calculate it's negative 3.78. Can you see what value this graph is getting closer and closer to but never touching? You can also look over here. Plug in a 3. Second enter for my previous equation. Change that 2 to a 3. Negative 3.93. There's that. And there's the curve to it. This is called exponential decay. It's called exponential decay because the graph is going down as it goes to the right instead of going up. But it still has an asymptote. And the asymptote is still that k value, which in this case is negative 4. I'm on my parabola tool. I'm going to be here. Negative 4 is tough to graph with the way it's set up right now, but that's the asymptote. The asymptote is the line y equals negative 4. It's the k value. The k value is negative 4, so that's the asymptote. That didn't work very well. Let's try it again. The k value is negative 4, so that's the asymptote. Right there. Right there. Why does this 1/3 to the x make the graph go down instead of up? This is a question that I'd like you to actually pause and think about and see if you can answer. Instead of actually pausing it, it's going to take me a while to take care of this, so just think about it right now. Okay, if you want more time, now you should pause it. If we're doing 1/3 to the x, 1/3 to the x, so I have 2, so suppose I did to the 5th. That'd be 2 times 1/3, 5 times. There's 1, 2, 3, 4. There's a 5th, and I subtract 4 at the end of that. Well, 2 times 1/3 is suddenly 2/3. We've taken 2/3 of the amount away from 2. It's 1/3 the size it used to be. Then it's the 1/3 the size again. Then you cut it into 1/3, and cut it into 1/3, and cut it into 1/3. And you've taken 1/3, you've broken this 2 into thirds 5 times. You've really got 3, 9, 27, 81, 243. You have 240 left. And then from that, we're going to take away 4. Well, this keeps getting smaller and smaller and smaller and smaller. It keeps getting closer and closer to 0, in fact, but it never actually touches 0. Then it keeps on subtracting 4 at the end, which is why we keep getting closer and closer to negative 4 without ever actually touching it, even though the line that I just drew clearly touched it. If this number is less than 1, the graph goes down. If it's greater than 1, the graph goes up. Now, don't say if this number is a fraction. It doesn't matter if it's a fraction or not, because this would go up. If it was 4/3, 4/3 is bigger than 1, so the graph would go up. It would be growth. It doesn't matter that it's a fraction or not. The fractionness of it doesn't matter. Let's do one more. So far you've seen me graph all these by computer. This one I'll do by hand, just so you can kind of get an idea of how yours should look. I'm going to make a table that goes from -3 to 3. Again, you probably can't always fit all these numbers onto your graph. I'm going to try and see what happens. And I'm just going to start plugging stuff in. I'm going to start by plugging in this 1. Why did I pick 1? Well, because if I'm plugging 1 in for this x. 1 minus 1 is 0. 3 to the 0 is 1. 2 times 1 is 2. Minus 6 is negative 4. Just the point 1, negative 4. That's a nice, clean, easy point for me to work with. Okay, I'm going to plug in 2 next. Plug it in here again. 2 minus 1 is 1. 3 to the first, so 3 to the first is 3, times 2 is 6, minus 6 is 0. Plug in 3. Plug in 3 here. 3 minus 1 is 2. 2 to 3 to the second power is 9. 2 times 9 is 18. Minus 6 is 12. I'll plug in 0. 0 minus 1 is negative 1. 3 to the negative 1 is a third. 2 times a third minus 6 is 2/3 minus 6, which you can do this in your calculator and make it all nice and pretty. It's negative 5 1/3, which is negative 5.3 repeating. I will show this in the calculator one more time. Another way to do this, and the smarter way to do this, then here's one method that I've shown where you plug stuff in over and over. The smarter way is to plug it into your y equals menu and do 2 times 3 to the, and then in parentheses, this has to be in parentheses in my calculator. Yours might be new enough that that doesn't matter. I do x minus 1, close parentheses, and then minus 6. If I wanted to, I could graph it and see how the graph looks, but that doesn't help me a ton because I can't get points from that very good. But I can pull up my table really quick. And right now, I just need negative 1, negative 2, and negative 3. I have negative 5.7, negative 5.9, negative 5.9. Ooh, don't freeze on me. Come back. Good. Negative 5.7, negative 5.9, and more negative 5.9. Call it 9.8 just to make it different. So I'm going to graph this. Nope, I want you. I want you. I want you. And I can see that it has a highest y value of 12 right now. So I'm going to have my y value go all the way up to 12. I don't need it to go beyond, like, much past negative 6, though. And I'm only going from, like, negative 3 to 3. So you're thinking, well, I can't do this on my screen, so how come you are? Oh, shoot, I have these x's and y's backwards, excuse me. But you can pick your graph just the way that I'm picking mine. You know, you can decide how high to go, what to count by. In fact, I'm going to count by 2s. No, I'll count by 1s. Sometimes you might want to count by 2s and count by 3s. I want to do my graph like this. You have control over your graph paper to try and figure how it's going to look. I'm going to size this and scale it down. So, I have the point 312, which is here. I have the point 20, which is here. 1, negative 4 is here. You can see how quickly these things decay if you're going backwards, how quickly they grow going to the right. 0, negative 5.3. 1, negative 5.7. I don't expect you to graph these ones very accurately. What I want you to do is basically just get on that asymptote line. Basically just get on where that line is going to be. And it's okay if you touch it, but try to not go underneath it. And with your straight edge, graph the asymptote. And somewhere on the graph right, the asymptote is the line y equals negative 6. Like literally it's a horizontal line. It's the graph of a horizontal line, y equals. And then for your curve, it's okay if you touch the line. I understand what you're trying to do. Just try not to go underneath it. And get at least 1, 2, 3, 4, 5 good points. They might get too big eventually. Like this one might be too big sometimes. But if you can get it to fit on your graph, please do so. So that's how your graph should look by hand. They should have 4 or 5 points, a good asymptote, an asymptote that you've labeled, the equation of the graph, and it's all on graph paper. That should take care of it. If you have any questions, let me know. Thanks.